Hi, Tom.
Hey, hello, Tom.
Yeah, actually, like we know Tom, I guess, for ages because of his great Unreal Engine course and some great collaboration with us in the past. And I just recently occasionally learned Tom actually lives in Amsterdam, where I do too. So we finally met in person. That was great. It's always great, to see the person like for the first time when you know him or her for like many years in the internet. So that was great. So yeah, thank you for like collaborating with us for a long time. And if you're interested in some cool course about Unreal Engine, you should ask Tom about it. He could like kind of recommend you one, which is great. Yeah. Okay. So Tom, before we start, my favorite question today. So what was the first game you ever created?
I guess the first game that I ever created was one based on Mafia 1. And I, like everyone that starts making games, somehow wants to make an MMORPG. So I tried to turn Mafia into an MMORPG for some reason. And I think I used some tool called like Realm Crafter, it was called. So it was mostly scripting. So I'm not even sure what kind of programming language it was. Maybe it might have been C# or something. And so, of course, that went nowhere, but it was still a lot of fun to just learn like so many things and do a lot of 3D modeling, because that's actually what I was more into at the time than coding. And so, yeah, of course, it went nowhere, but I still managed to sell those assets on TurboSquid at the time. So I made a little bit of money on it, even though it never turned into a game at all. So yeah, that was my first game-ish.
Sounds cool. You should probably send me a link.
Yeah, I have it. I have some screenshots somewhere deeply buried in my Google Drive.
Okay, cool. Okay, Dan, the stage is yours, I guess. You can start.
All right, thank you. So welcome to my talk, Unreal Engine game optimization on a budget. And in this case, on a budget mostly refers to like cheap, easy to do optimizations in Unreal Engine, rather than writing complex custom systems. I'll show you some custom systems, but mostly it will just really be checkboxes and out-of-the-box features that are available that you might just not know about, or not know, or not sure how to use. So we'll be showing a few built-in profiling tools and commands. I'll show you some easy optimization opportunities and the significance manager. And I'll finish off based on how much time is left with, so like a did you know that this existed? Because those are always fun. So first off, who am I? Well, I'm Tom Looman. There's my Twitter handle. I started off at Guerrilla Games a long time ago. I had a little bit of time at Epic Games as well. But for the most part, I've been an indie developer and Unreal Engine consultant, just helping studios, well, in this case, optimize their game. So that's what some of these findings came from, and some of these screenshots are coming from as well. And I've been using Unreal Engine for probably more than 10 years. Started with Unreal Engine 3, actually with Unreal Tournaments modding, but that was like much earlier as well. And I spend a lot of my time creating Unreal courses and tutorials. So I have a Unreal Engine C++ course, and maybe hopefully later this year I hope to have a actually game optimization course. So this could be sort of like an introduction to that. So before you start profiling, every talk starts off with a few things to remember to do. So I'll just repeat those here. You want to start off with disabling VSync, disabling any kind of max or FPS limiters, set your smoothing of the frame rate to false in your project settings. And make sure your lighting is built, because if you have unbuilt lighting, a much slower path will be used, and it basically kind of invalidates a lot of the profiling that you're doing. And it can also really help to have map check errors fixed. This is done with, this is very useful. For example, maybe over time, some assets became corrupt or have invalid materials, or just set up incorrectly. This can have especially effects on what could be performance, but it could also be like load times could be affected by this. And of course, it's ideal to use a packaged game for your profiling, but I can imagine that standalone is very convenient to use, and I also do that sometimes. But make sure that timings and especially memory can be quite out of sync, because it might be that, especially in non-cooked builds, it uses different paths for loading assets, and it will still have a lot of metadata of the assets still loaded in. So be mindful of that for sure. So then you start off with finding the bottleneck. So you might be bottleneck on the game thread, the render thread, or the GPU. Of course, it could be other things as well, but these are like the three main bottleneck areas. For that, we have Unreal Insights. That is one of the tools I'll be showing today. We, of course, have the all-time favorite profile GPU with the option to first run r.rhi set GPU capture options 1. That's a whole mouthful. And what that does is it enables a bunch more console commands in order to give you a much more in-depth information when running profile GPU. One of those things will be individual material and draw calls information, so you can actually see what went into your base pass or into your shadow rendering, rather than just seeing the total cost of your base pass, the total cost of your shadow rendering. So it can be very useful. But of course, that is more expensive. So keep that in mind. Don't enable that and then start doing Unreal Insights, but just enable that and then just do your profile GPU. And then, of course, you have the things like stat unit graph or even stat detail that gives you the most information on frame timings and all these individual threads, like the game thread, render thread, GPU, and gives you a nice graph to see if your frame rate is actually stable or if there's some kind of itching going on as well. And then you have things like our screen percentage. If you set that to something really low, like 20, which is like 20%, you can see. You can get a kind of an idea whether or not your GPU bottlenecked if if there's no change at all. And the same is true for a pause. If you pause your game, this will actually freeze the game thread from ticking and running a lot of its logic. So that can sort of like give you an idea whether or not the game thread is affecting your performance or not. And then with memory loading, we again can use Unreal Insights with, I think with Unreal Engine 5.0, the memory profiler got a lot better in Unreal Insights, so that's a very interesting one. I haven't been able to deal with that that much yet because the games that I've been helping optimize are still in Unreal Engine 4, but that's a very exciting new feature. And load time and file are other categories for tracing in Unreal Insights that are very useful for finding individuals, so seeing all the individual assets getting loaded and how long they take and when they get loaded exactly. And then we have other tools like Memreport, load times DumpTicks. I'll be talking a little bit more about all of these throughout the talk. So then let's first have a quick look at Unreal Insights. Don't worry that this overview is not really readable. It just shows you one frame, including all the individual tracked and traced function calls. And so the really powerful thing with Unreal Insights is that it can give very detailed CPU and GPU insights, memory insights, file loading, like when a file is getting loaded and what will happen on the CPU once it's loaded. For example, after it gets loaded, maybe it has to create a physics body, and you'll actually see that all on the timeline. And you will see all the threading information, which is really powerful as well. You can see how threads follow each other up and what is running where exactly. So I'd like to give a quick overview of Insights without this becoming a whole tutorial for Insights specifically. So in order to run it, you want to run your game with dashed trace equals and then the categories, the trace channels that you're interested in. And then the dash stat named events gives you additional name information. I think this is especially for the CPU tracing. If you want to know all these trace channels, there's the rather long URL there, which has all of them listed as well. And you can run this in the standalone game when you specify them as additional launch parameters. But of course, running this in your package game is going to give you more accurate results. A really interesting thing to do, to add and to use is bookmarks. It already exists for garbage collection, sequencer start, which is like for your cinematics, level streaming when they get requested and when they are completed, and whenever you do a console command. So when you, for example, run r.screen percentage 20, it will show up as a bookmark in the timeline of your insights. So that's very helpful. And you can very easily add your own bookmarks by just having trace_bookmark macro through your C++ code, and then adding some string to identify like what was going on. So this could be any kind of gameplay context you want to give during this profiling session. You can also add your own stat profiling. So this is very helpful in order to get additional information and sort of like break down bigger functions and their costs into smaller pieces that are originating from your own C++ game code. I have a blog post about this for more details, so we can sort of like skim over it today. And it's really powerful because you might have a function that only says blueprint time, and it might be 1 millisecond, but you don't know exactly what's going on in that blueprint time. But it might be calling a bunch into your C++ code, specifying your own stats macros will give you much more detailed information. Like, okay, actually this code of us is actually taking up a significant portion of our blueprint time, for example. And as some quick tips. It's useful to run some commands during the session. So, for example, you can use pause to pause the game thread and really see how this affects possibly also your render thread, because some things from the game thread get pushed into the render thread, such as skeletal mesh updates that happen in the start of your game thread, and then they get pushed into the render thread, and then that gets pushed into the GPU. So if you pause your whole game thread, then you might see this having an interesting impact on your render thread and sort of like get a better insight into how they operate. And it's a good idea to only use the necessary categories for lower overhead, because the more trace channels you use, the heavier the profiling is, and so that might have an impact on your profiling. And of course, add those custom bookmarks for gameplay context, because you don't have a visual element to inset sessions. It's just a big timeline with all the threads. So you might get lost on when things were happening. So having some bookmarks, even for example, when your character interacts with an object and then some puzzle thing happens, it might be nice to just add a bookmark to that code and then have a better insight of, okay, this is when we triggered some interaction code, and you can dig deeper into that frame specifically. Then Memreport with the optional parameter of -full. It runs a bunch of individual commands for memory profiling. One of the really nice ones that I like is obj list class, and then you can specify a class, for example, static mesh or atom sequence or body setup. And the Memreport gives you a pretty good initial overview of like, okay, how much memory is a certain category using. And then by using obj list class and specifying a specific class, you can see from within a specific category, like atom sequences, you can actually see, okay, which is our most expensive animation, and why might that be? So here, I hope this is readable. This is one output or like a section of the dump log from a obj list class atom sequence. And so you see the paths to a bunch of these assets. Now, these assets are actually really cheap because the columns are showing the size in kilobytes. So it's like between 7 and 1 kilobytes. Others would be much larger, but they fell out of the screenshot. And there's two things really interesting here. The first one saying, is any object much larger than expected? And the other one is, are there any objects here that we don't expect to be in memory at all? Very easily, references get introduced in our reels, so very easily you accidentally load things in that you don't want to have. And so this is a very good first look at seeing why that might be happening. And then you can use other tools such as the reference viewer to investigate why that reference might exist and why it might have been loaded. And of course, make sure you do this in packaged games, ideally, because if you do this in the editor, you get some idea of course, what it might be loaded. But again, if you have opened up some window before in your session, that might still be in memory. So it's already skewing the results. And also, for example, with atom sequences, they're probably at least twice the size in the editor rather than in a quick build. So now let's move on to DumpTicks. This is a super useful little feature, like a console command. You have DumpTicks. You also have DumpTicks grouped, which gives you more of an overview of like, okay, we have 17 of this component securely ticking. And it outputs all the actors and components because they, of course, can tick independently. If you have disabled actor tick, it has no influence on the actors components, whether or not they are ticking. So using this to dump into the log and investigate, like, is there maybe something ticking that I wasn't even considering existed or is definitely not currently relevant, then you can have a bunch of ways to fix this. Either you just disable ticking on it entirely if it never needs to tick. You can use something like level streaming to load it in at a later time, or you could maybe use something like significance manager to manage the ticks, whether or not it should be ticking based on certain parameters, which could be distance to, like based on if it's more than 10,000 units away, we currently don't have the tick because it's not going to have any meaningful influence on the gameplay or frame. Then list timers is another useful thing to have an idea of like what is actually currently has been moved into timers, and make sure that you run it on a low enough frequency, because what might happen is if you set it on like a 60 hertz frequency and your game on old gen is running on 30, what might happen or what will happen is your timer is just going to run twice a frame, and it's not nicely spaced out. It's not super smart about being some kind of asynchronous function where it runs twice equally spaced inside of your frame. No, we'll just tick the timer twice, which of course is super wasteful. You're just actually making it worse. So make sure that if you use timers, make sure it's actually an optimization. Another good thing to keep in mind is just avoid heavy load. Otherwise, you just get very stuttery frames. If your solution to optimizing your tick is to just move a very expensive function to a timer, it might not be a great idea, because the thing is, then you sort of get these, like I was saying, these stutters, these hitches. And if you have a moment where other expensive stuff is also happening in that frame, maybe a bunch of actors get spawned in that same frame, you suddenly have a huge hitch. An alternative to that would be either to optimize the code itself or to use something like time slicing, where if you're iterating over some kind of array, to only do the X number of objects every frame. Of course, it is a little bit more complicated code. So ideally, you just don't want to do that within this on a budget. And then we have stack U objects, which I really like because it sort of like dumps all the, or currently shows all the ticking U objects on screen. This is really nice because pretty much anything kind of derives from U object in a way that would be ticking. So your character mesh would be included in here, all your blueprints would be included, or your other components, anything that's in the world would be listed here as it's updating and it's ticking. And you can very easily see either things that you weren't expecting to be ticking or that are taking up much more time than you were expecting. And so that is really nice. And they're, in that case, I believe they're grouped per class. So if you have like 17 of a particular blueprint ticking, then they are accumulated as a single time. So you can see like, okay, we have way too many of these ticking and they're taking up 2 milliseconds. We should really investigate this. Then a quick note on like collision and physics. Like Unreal Engine is configured to be very to just work and be very pretty out of the box. Like immediately your physics will work. If you like simulate physics on an object, and it will just roll around and interact with everything. That's really nice. But the downside is it's kind of heavy, and a lot of games don't really need this. So if you look at the character movement, that's actually not using physics. It's not using any kind of forces. It's actually using queries to sweep and check if it can move forward or if it can move down with gravity, and if it can slide along the floor or like along the wall, rather than actually using any kind of physics simulation. So a lot of the times you can disable physics on objects, and whenever the object is at the collision enabled, that actually means that it's both physics plus query. So you can set it to query only in many cases, and that avoids the object and its collision from being injected into the physics engine, which is just a waste of memory if it's a static object, but it's also even worse when it's a movable object, because then it will constantly have to move within the physics engine as well, even though you're never really using the data from the physics engine. Another thing it's very useful to do is just disable collision on all the components in the world that can't be reached by the player or that the player can't interact with. Again, this will reduce the load on the physics system and on the collision, but it will also just save some memory. And in order to figure out how much memory that's using, one way to figure it out is using again obj list class as body setup. That can sometimes be 100 or even 200 megabytes of data that for the most part might be sort of like a waste. And especially on older gen hardware, this is kind of a problem because you don't have a lot of memory to work with. But at the same time, this also wastes a little bit of time during loads because you're creating these objects. When you're spawning an object, it has to create a physics body and insert it into the physics engine. So it's just an easy way to reduce the load. And then with stat physics and stat collision, you can get more information about what is happening in a frame, how many line traces are happening, and how much time it's taking. Another thing I really like is show collision pawn and show collision visibility, because these visualize in your viewport the current objects and the shapes of your world and how your pawn, how your player will interact with that, how it's getting blocked on that channel. So pawn and the visibility are those channels, and that's very useful because you might be surprised just how many things are set to collision. You can also see just how complicated some collisions are. I mean, especially if you use a lot of marketplace assets, they might just have tons of convex hulls for no particular reason other than that it's very accurate, but it might just be a waste and be heavy on memory and on performance. Another quick tip: landscape. It can use lower MIPS. You literally have a variable or two actually called collision MIP and collision MIP simple, I believe. You can use a higher one, maybe 1, maybe 2. It really depends on your landscape. But this can significantly reduce memory and reduce CPU cost, because your landscape can be quite detailed, have millions of triangles, and your collision may not have to be that precise. So then on to moving scene components, especially when you're dealing with just moving up those components and doing that in Blueprint. It might happen that you accidentally move it multiple times in a frame, and it can be a move or a rotate. If you do that, make sure you just call set actor location and rotation at the same time, rather than first moving it and then rotating it. Because in this screenshot, as you hopefully can see, on the right we have those two chunky blocks with move component with a yellow bar. So here we have a little robot that is first moved and then it is rotated. So we spend time updating all of the component transforms on all the scene components twice, and then we're triggering overlaps on all those components twice. So that might actually have a gameplay impact where other overlaps are getting triggered twice in your game world if you do some kind of gameplay with that. So that's definitely a useful thing to consider, and you can very easily find these things with Unreal Insights, which is super nice because it might be much harder to find by just being in Blueprint. One way to go around this is using a movement component. You can create a custom movement component in C++, write your logic in there, which is not that difficult to do. I actually hope to have a blog post about that soon to make sure that people know how to do that. It's rather easy. Again, disable collision, very helpful. Just disable anything that doesn't really need it, or set it to query only if you do really need it. And generate overlaps is also very expensive. Again, you can see here that it takes a bunch of time to generate and react to all those to that movement. So just disable it when you don't need it. Another nice trick: auto-manage attachment. This is built in on the audio and audio components and the Niagara components. I mean, also some Cascade, but it's being phased out. So the cool thing about this is that while the audio is not playing, or while your Niagara system is disabled or like not doing anything, with auto-managed attachment, it will just sort of like detach itself from your player, from your whatever gameplay actor you have in the world, and it sort of like sits in wherever, like world 0. Only when you then activate the sound, it will reattach itself. And the nice thing about this is maybe your audio is not going to be active for a long period of time, or that particle is only happening when you're shooting something. The rest of the time, you're no longer paying for moving that scene component. And in order to profile this, you have stat components, which gives you some insight into how much time it costs to move all those components in a frame, and also how much time you're spending on calculating of the bounds. So that's the next thing. You can enable use attached parent bounds on scene components, and then the nice thing about this is it will use the parents bounds that are already calculated. So here we have an object on the left, the bottom left, is a moving little robot, and every single scene component there, which it has a lot of, has its own bounds, but they're mostly the same anyway. So we might as well just reuse the parents bounds instead of individually calculating them for all of these components. And in order to visualize this, you have either in game you have show bounds, or in the other you have show bounds or show flag.bounds 1. And here in our insights, you can see highlighted all these are all the cap bounds that are happening in that same movement that I showed earlier. And individually, they're really short. They're really fast to do. These are not particularly complicated, like most of them, but it's still a wasteful, and it's super easy to just make sure you reuse the data that's already available, especially if you have actors that have 50 components that are being moved constantly, or you have a spaceship that is consistent of like tens of or even hundreds of actors. The other thing you have to keep in mind is, for example, if you have a character and has a sword in his hand and you're using the parent bounds of the character, make sure that when that sword can never really go out of the bounds of the of that player character, because otherwise, maybe if your viewer is only going to see the sword, it will sort of like disappear because it was not in the bounds of that character mesh. So do keep in mind that things might get out of bounds, so you have to be mindful of that. Then a quick word on Significance Manager. This is another nice system that is mostly just an empty framework. And the point of the use of the system is to use your game code to figure out whether or not an object is currently significant and should like do all of its sticking and all of its traces and everything, or if it's really far away from the player and it's no longer significant, so we can skip on a lot of these things. Maybe we just disable all the traces, or we reduce the tick rate, or anything like that. One easy way to do that is with a distance to, just out every frame based on the viewport of the player. You check the distance to that object, and based on that, you compute a significance value. There's no set way, but an easy one would be from 0 to 1. You really decide. And based on that, you can react to it. Say like, okay, when it's 0, it's really not significant, so I'm just going to disable a whole bunch of stuff. Unreal doesn't really specify how to use this, so it's really up to you how to implement this and what your considerations are. The way I've seen Epic use it with Fortnite and Paragon is that they put their objects into buckets. So maybe on the platform, you might have 5 players in a multiplayer game that are in the first bucket, so they are always able to be on the full fidelity. That might be your own player, but also could be like your teammates, for example. They would be first. They would be the most important ones. But if your teammates are really far away, then maybe some other player that's really close by, so MED player that's really close by, is in the first bucket. And then there's some profiling commands available, but also there's an example that I've been working on. A really simple example. In this case, I made a significance component to really easily add this onto other objects. And the nice thing about that is you don't need to have a C++ base class in order to implement this. You can just have, you can add this, C++ component to your blueprint classes, and then very easily implement what it should do, when it gets insignificant. And I'll be hopefully making a blog post about that soon as well to give you some more insights. Now let's move on to occlusion culling. With the frustum culling and occlusion queries, we can prevent a lot of the meshes from actually being rendered. But if you have thousands of actors or thousands of components, this in and of itself can be really expensive to even consider. So you can spend 10 or even more milliseconds just trying to figure out what it should be rendering. That can be quite wasteful. And by the way, how occlusion queries are pulled, they are actually pulled in the next frame. So a bunch of queries are being sent out, and then in the next frame they'll be used. This is why you might also be seeing some popping when you're moving your camera around really quickly, and there's a lot of contrast between maybe the meshes that are being rendered and the background. So that might actually be because there's a 1 frame delay that you might miss and have a hole in your geometry for a little bit. But the alternative would be to actually wait for all those queries to be done, which is also not ideal because that even makes it all a lot slower. HLOD, so hierarchical LOD, can greatly reduce occlusion costs. Here in the screenshots below, you can see just how many. So those green boxes represent an object being occluded or having been queried, actually. And on the right, we made this mesh, that little building, into an HLOD. And so it's only one mesh once you're far enough, once you're pretty far away from it. But when you get closer, it gets replaced by all the modular pieces again. And in order to profile this, the main one would be stat in and views. This gives you a really good insight into what actually is going on and how many queries have been triggered, how many objects have been frustum culled, before even being bothered to have been queried. And with the art of visualizing fluid primitives, you can actually see that visualization happening. Another tool I really like is RenderDoc. It integrates pretty nicely with Unreal as well. And you can see the occlusion results by using the depth test overlay in RenderDoc. I won't go too deep into how you get started with RenderDoc, but there's some documentation and videos about this, so it's really, really nice. And by using depth test, you can sort of see these boxes, because of course the queries are using boxes, not the actual geometry. To see like with the green pixels that have passed the depth test, so they would be visible, and then the red pixels are not visible, so they are occluded by other geometry in the depth buffer. So there's always a pre-pass where only the depth is being rendered, and then based on that, it starts checking the occlusion queries and seeing, okay, is this object potentially visible or not? And with this, we can very easily find wasteful queries. So there might be a ton of really tiny, completely black or completely red, sorry, boxes far off in the distance, and that would indicate we're wasting occlusion query time by doing these tiny queries that are never going to be never going to succeed, or even if they do succeed, they do have green pixels. They still have a problem that they're not going to be contributing all that much to the frame. So one way around this, or one first optimization you could do, is distance culling. You can set on primitive components, you can set a min and max draw distance, which is super useful for things like light cones, fog volumes, or blueprint components on maybe on your character or other gameplay actors. But of course, it's really tedious to set this on everything manually. So there's also distance cull volumes. And what this does is it maps the size with a cull distance. And so maybe your object size is 25 and your cull after then 2000 units, you cull it and you just stop rendering that object. That is super useful as it reduces a lot of the load on occlusion queries. And in order to profile this, you can again use stat in views or show flag.distance culled primitives 1. Setting that will actually forcefully render them anyway. And so you within your stat in views, you can also see the difference, like how much cost is that adding, or how many more queries is that not adding that we're force rendering it anyway. Here's an example of using min and max draw distance. So here we have light cones in a hallway, and we're using shader complexity visualization to show the pixel overdraw. And then we have the distance cull fade, which is a node inside your material, which is really cool because that will blend between 0 and 1 and 1 and 0 when it pops in and out of that min and max draw distance threshold. So that can really help you reduce the popping effect. Otherwise, it will just pop in and out, and that might be a little jarring. This helps it a little bit by blending it in still pretty rapidly, so you might still see it, but it's much more smooth this way. And in this visualization, you can see the white pixels are really awful. They have massive overdraw, so it can really affect performance. And on the bottom screenshot, you can see that we have significantly reduced it by both using the min draw distance to something so that the biggest light cones also get culled, because you might want to fade them out anyway because they just be a big bright blur over your screen when they're so close. And really far away ones also won't contribute that much to the frame, so we're skipping them as well. And then to verify that your occlusion, all your occlusion setup is actually working, freeze rendering command is useful to like stop doing those queries and checks, and actually with then semicolon you can fly with the debug camera, fly around. You can still walk around as well, by the way, but you can fly around to see if there's things maybe behind the object that were still being rendered that are somehow not occluding, or maybe there's this giant mountain that should be off screen but is somehow still rendering, probably because the bounds are just really large because there are some geometries sticking underneath the terrain that you didn't notice. So this is a nice way to verify that it's actually working as intended. Then another really easy but manual work optimization is light culling. There is a built-in screen size culling that's not really strict, and probably shouldn't be too strict because it will start popping those lights in and out. But once your light gets small enough on screen, it will already stop rendering it. But we can call this much earlier on a case-by-case basis. For that, we have the max draw distance and max distance fade range on those lights, on point lights and spotlights, and also on area lights. And the max, the fade range here really makes it blend in and out properly. So then it prevents the popping. So you might set your max draw distance, I don't know, to something like 3,000 units, and then like 750 or 1,000 units to fade it in. So once you're outside of that total range plus the fade range, it no longer adds any cost to your scene because now it's properly culled. So make sure you use this without the player noticing that lights are actually being blended in, but this can help really reduce shadow costs and light projection costs on a lot of lights. And in order to visualize this, you have like show in your viewport, like show like light complexity and the stationary light overlap. And also the toggle light with using a name or a partial name. So you could also just type in toggle light, point light, and then it will disable all the point lights, which can be useful if you have a particular light. You just want to toggle it, see what the impact is on the current frame. Then level streaming, another really nice feature. Will still be relevant in Unreal Engine 5, even though there's a lot of things changing with Unreal 5 rendering. This is great actually for a number of reasons that I'll go into in a little bit. But the way we can do this is by using streaming volumes, or we just manually unload and load those streaming levels. It's important to note that they're camera location based. So if you have a third-person camera that like has a pretty large distance to the character, be mindful of that, because your camera might suddenly stick through a door or like be very close to some volume and then suddenly start loading this volume behind that door, even though you're not supposed to yet. Or with cinematic shots, you might have this wide angle shot that looks awesome, but suddenly your camera is in a different location in the level, and so that might affect the level streaming volume as well. You cannot combine both the volumes and manually loading, unloading on a specific sublevel, but you can mix and match between sublevels. So for example, one sublevel, you just use it with streaming volumes, and the other sublevel, you manually do it based on some trigger volume, based on some game logic, based on a cinematic or something like that. And in order to profile this, like what is being loaded and how much time they're taking, and stat levels will be really helpful in order to see like in red which is loaded, or green which is currently loaded, red is not loaded. And then we have load times at Memreport, which will output again to the log a bunch of information like what was the individual asset loading times for each of them. Again, Unreal Insights is super useful here with like load time and file categories. And then for the bookmarks, we have the load levels when they start and end is being shown in the garbage collection, because it's streaming in and out a lot of these levels constantly will cause like a lot of objects being destroyed. So you have to be mindful of your garbage collection and be sure that that's not going to be hitching. Then for the performance impacts, it really helps with the initial load time, because a lot of the levels don't need to be loaded immediately. You can sort of like delay and load them in later. Occlusion cost is a massive one, because even when you load a level, you might not have to make them visible immediately. You can just load them and keep them invisible, which is one of the options with load not visible, or just load. And when it hasn't been loaded in before, it will only load and not make it visible yet. And that can really help with occlusion costs, because they don't actually exist in level yet. So that can be a big win. And then of course for memory, if you don't have them loaded yet, you can still, again, get a lot of memory, because by the time you might reach that level streaming point, you might have already unloaded some other level streaming volumes behind you. Just a quick note, keep it in mind early for your level design, because it might really influence how your levels are set up with line of sights, like natural corridors and points of no return, all the classic examples. But also it might it makes the job a lot easier once you actually have to get into level streaming, if things have already been considered for level streaming. So we have animation fastpath. Fastpath is really nice because it allows us to run a faster path on the animation nodes that don't have to call into the Blueprint virtual machine, and rather can use the fastpath for animation. But in order to do that, you have to move all your computations out of AnimGraph and into EventGraph. In order to know what you need to change, you can just enable warn about Blueprint usage in the class settings of your animation Blueprint. And this will warn you about any violations of that. And a violation won't fail, it won't crash or anything. It will just tell you like, well, we're using slow path now, so you're out of luck. And the one downside is you have to move it into EventGraph, so your logic is a little bit more removed from the anim graph where you're actually using the data. And any computation, like even having a variable multiplying it by 2, that's a computation. So that will no longer be able to use the fast path on that node that you're plugging it into. Same with select nodes or any kind of thing that's not just getting the variable is going to be considered a warning. But this can really significantly improve your animation performance because it can do things more multi-threaded and don't have to run the slower blueprint path. Another one, some animation quick wins, just some rapid fire things to look into. Update rate optimization, URO, for distant skeletal meshes. This can be really nice because for distant meshes, you don't always have to tick the animation super precise every frame. You can skip some frames. This is a checkbox and something you can configure in the skeletal mesh individually, which can be very helpful if you have a lot of skeletal meshes at once on your screen. That might be not all super relevant at the same time. Then the visibility-based anim-tick option. This is another one that I think is quite refreshes and updates every frame, or even if it's not necessarily being rendered, because that's the option that will definitely work, but it's not the most optimal option. So we can use only tick pose when rendered, which will reduce the amount of load on all your skeletal meshes when they are not necessarily relevant for you currently. So you can set that in the individual skeletal mesh, but there's also a configuration option, and then you can still override it in the individual components in order to make some easy optimizations there. Then we have some more booleans just to look into for you. Like render a static is really nice because that will render a skeletal mesh as if it was a static mesh. So we use the reference pose for that. This can be useful if you have things in the world like weapons, for example, or other things that actually have a good reference pose. Like characters might not have a good reference pose; they look T-posing. But this can further reduce the cost because, again, if it's being rendered static, it doesn't have to update it in the game thread and then push it into the render thread and then the GPU in the same way as with a static mesh. It's just a cheaper path. Pause anims and no skeletal update can again be useful if you have things that need to exist but don't necessarily need to update. You can manually set this. This might be a good one to plug into your significance manager based on some distance or certain conditions. And another thing I wanted to point out is animation compression library. This is not built into the engine yet, hopefully in the future. It's made by Nicolas Frechette, and it has been super great for the games we've been working with. Is that, for example, one of the things is the compression speed up is massive. It's literally been at least 50 times faster, according to his own measurements, like 56 times faster. And it really makes your compression go from minutes to seconds. So this is just a really nice day-to-day workflow improvement, especially if you have a very animation-heavy game. Decompression speed, massively faster, which is super nice for your load times, and then memory size and for streaming as well. And then memory size was cut in half for our game as well, which is super great because we were really memory constrained. It also reduces the disk space size, but I haven't really measured that one in particular. But the memory size was pretty significant, and that was the most interesting one that we really needed. And it's used by Fortnite and other AAA titles, so it's not like an experimental plugin at all or anything like that. So eventually, hopefully built in Unreal Engine 5, we'll see. Another thing I just wanted to point out, without going too deep into it, is the Oodle data and Oodle texture plugins. This came in pretty late in Unreal Engine 4, but it's super useful because Oodle data is part of the packaging process where it will compress your assets to be significantly smaller than the default compression. And then Oodle texture is specifically for the texture data. So what it can do is it can use RDO, rate distortion optimization, to significantly improve texture compression, but up to something like 50% or something crazy, with very minimal differences in texture quality. And you can really crank that up a lot more. The defaults are pretty lenient, so that they just definitely look really great and still have big gains without really crunching the textures too much. It does take longer to compress, so by default, as you can also see in that screenshot that hopefully is readable, enable an editor, like the fourth line or something is enabled or is disabled by default. So it's not going to be compressed or not going to be used by default in the editor. But if you are, because it is meaningfully slower than the default compression. And then just to keep it short, like RDO that works with Oodle data, and it's by preparing the data for it. So you still need Oodle data in order to really benefit from Oodle texture, but because it just shuffles around the data to be more compressible. There's more information on the documentation as well, and some really cool blog posts from the guys at Oodle or that made Oodle. Definitely worthwhile to look into. It has significantly improved the package size and also a little bit of load times. Once the texture is in memory, there isn't really any difference. That's not what this does. It is really about being much smaller on disk and having a much faster loading path. Another one I quickly wanted to point out, CPU and GPU benchmark, the SynthBench. It's a nice little tool in order to run a quick benchmark when the player first launched the game. And it will give you a guideline of the CPU and GPU capabilities. And this, of course, is mostly useful for dynamic platforms such as PC, because they will have a dynamic result base, and with the baseline being 100, like anything under 100 being like below average speed. So you might have to scale down, going away from Epic, for example, and going to like lower medium spec. And you can use the CPU multipliers and GPU multipliers to easily like tune based on your specific game. So if your game is very GPU intense, you might use a lower multiplier so that the scalability throttles down sooner. I again have a blog post about this to go into a little bit, and it references some more documents and more videos to really know how to implement this. But it's going to be quite nice to have some base level scalability options set on your PC so that your user doesn't run everything on Epic and then has 10 FPS and has to go manually figure out like what is some decent options for my rig. Again, another one I really have to be short about this is like shadow proxies. This is a bit of a destructive workflow, but it can be really nice if you have a lot of modular buildings, a lot of modular geometry in your world, because it can merge your assets merge your geometry into a single low poly silhouette mesh for your shadow rendering. And then you just disable render main mask on that object, and you disable shadows on all those modular pieces. This can have significant benefit for your shadow rendering potentially. It is a little bit of a destructive workflow. It's not, in that sense, it's not great to do it while you're still iterating on the level. But what I'm really hoping for with Unreal 5 geometry script is that maybe we can automate this a lot more. This is definitely something I would like to try out in future. Then SizeMap is another nice tool to inspect the disk and memory size of assets. And you can really easily find unexpected large references or bloated content. Like maybe there's some texture that you're not even expected to be referenced by your player character through hard casts and other odd references. Somehow you're loading in half your game. This gives you really good insight into what is happening and why, or like at least what is all being referenced and being loaded in based on some blueprint or some sub-levels, and it gives you some quick opportunities to find ways to like which asset is the problematic one and can be optimized. Another nice one, statistics window. It stats on the current level. There's a bunch of categories. The main one has what I use is the primitive stats and the texture stats, and that will give you a nice insight into which assets are being used in your level, which textures are being used in your level. And with using shift click, you can have a secondary sort, which is really nice because that maybe you can sort by count and then by triangles or by size. And then you can find assets that are really large in memory footprint, but are maybe only used once. You might have a bunch of different barrel variations or rocks or something, and that variation is only used once, but it still uses use of the full memory of that, right? So this can give you some easy insights into maybe we should replace that asset with another rock variation that we already were using. And then to close it off, some other useful commands that I wasn't able to put into the other slides. Toggle force default material. This will actually force rendering of the default material, which is really nice because that has a big influence on your base class. And you can really see just how much your shaders and switching shaders and having all of these instructions has an influence on your base pass. Dump hitches can be nice in order to figure out when a hitch has occurred. It will give you sort of like a stack trace, like what was the expensive function that might have caused this. And then finally, stat none, because we've been using so many of these stat categories. If you just type stat none, it will clear all the categories on screen, which can save you a lot of time instead of having to type all those categories again to disable them. And then finally, more of a niche option like Art Force LV Shadow. This can be especially useful again for the older or like the less capable platforms, because this forces a lower LOD to be used, even if the object is nearby player, for like cascade shadow maps or general shadow rendering. And that can significantly reduce not the draw calls, but the triangle counts being used. So in certain scenes, we tested this and we had like more than 1 million triangles reduction on a not even that significantly high poly scene by just using a higher blood shadow. Of course, this might change the silhouette of your geometry of your shadows a little bit, so make sure you have decent LV set up. And this might change for with nanite, so we'll see how that goes. So that was my talk. Thank you for your time. I don't think there's that much time for questions, but let's see.
Don't worry, there'll still be time for questions. Thank you for that. It's a fantastic talk. Lots and lots of great details in there. It's good. In fact, I mean, there's a lot of things. Sorry?
Now I can hear you.
Oh, you can. Are we good?
Yeah.
Great. All I was saying was it was a great talk and lots of great details in there. There's a ton of details. There seems to be a lot of stuff in there to remember. Lots of different things. Oh, Sasha's lost his hat.
Sorry.
So yeah, lots of things to remember and everything. How do you sort of recommend knowing what to look for? Because there's lots of things covering lots of different areas there. How do you know where to go to look for?
Yeah, that's a great question. I think one of the ways is, the documentation does have a lot of this stuff listed. It just might be difficult to find. There's also some nice blog posts throughout the internet that have a lot of this information available. Other talks from previous years on Fest, for example, that's where I got a lot of my information from. A lot of that wasn't included here because it was already in another talk. And a lot of it is just really trying. I think especially early on when we weren't really sure what to do, we were just browsing the details panel of these objects and seeing like, okay, what checkboxes are available on these skeletal meshes? What can we start playing with? So yeah, that's really been a way to just experiment. And honestly, for me, it's already been like many years that I've been sort of like dealing with this. So slowly over time, also by being on Twitter, like people like Chris Murphy always have these great tips that you're like, that existed? Wait a second. And there's always these things happening. So just sort of like being in the community really helps, and just experimenting. That's kind of like how I've had to learn it. And of course, there's documentation available.
Mm-hmm. I guess coming at it from a slightly different angle, though, how do you know how to apply this stuff? Which things should you apply first? Because this is covering lots of different things, like animation, graphics, physics, and so on. How do you know then which thing you should be tweaking next?
Right. Yeah. I guess that's where really the profiling comes in. So you have the Unreal Insights and you have that stat unit graph that I showed at the very start. That's going to give you some idea of where your bottleneck might be. So that's really where you should be focusing on. It doesn't make sense to do those game thread optimizations on your game objects if you're not game thread bottlenecked, because it's not going to give you any frame rate at that time. So make sure you work on your bottleneck first. And this can, of course, be, take a little bit of time of really understanding what is run where, but that's where, of course, Emerald Insight really comes in, because you can see the individual threads, like you can see the game thread, render thread, and then the GPU. So you can sort of see based on those categories, okay, actually the skeletal mesh is being updated in the render thread here. So maybe we can start looking there what we can optimize.
Cool. Alex, do you have any questions?
Yeah, I'm just sorry in advance. The sun has sunsetted and I wasn't prepared for it, and my light just can't work through. So we have actually a question from your student, Tom.
Okay.
I want to know why the cooling is having so bad performance. Does frame pacing affect it? Hardware occlusion cooling queries are the cause of making the GPU so busy? Or is the phone GPU sleeping for so long?
So the question was about why occlusion queries are so slow.
Practically, yeah.
Right. Well, in the case that I was showing is it just has to do a lot of queries, and then it has to get them back in the next frame from the GPU. So of course, getting things from the GPU isn't so fast, but it's just a lot of objects to consider. And so that's really why you want to help it out. We know a lot better than the GPU what we want to render, especially we have things like level streaming set up. We know like, okay, this entire interior is not going to be relevant for a while, so just make it invisible for now, so that the GPU, which is not smart, it's just really fast, doesn't have to consider all those objects anymore. Because it's literally, it could be thousands of occlusion queries, and that's just naturally going to be slow because it has to render a simple box, but then it has to figure out which pixels passed the depth test and which pixels did not pass the depth test. So that's takes some time to figure out. I hope that answers the question, if I understood it correctly.
I hope so as well.
All right.
The very last question from me, like, how do you figure out that the game actually needs the optimization? I mean, the thing is that you can run for so long, and at some point you actually like miss the optimization that was like tech debt that we made for long ago. So is there an option to have like a per stat for CI/CD and statistics of the performance of your game? Oh well.
Yeah, so there are ways. I mean, there's not, from what I know, it's not like super built in to have this automated process. And again, that's more of like a complicated system set up for yourself, where you might just run the game, use a command to like jump to some camera bookmark, and then do a quick profile GPU, or run some command to dump the profiling stats to a file, and then read that out. That does require some manual work. That's definitely something I would like to explore, especially now with like the editor scripting getting like much better all the time. But there's not really a really great option to have that dumped out daily through the continuous integration system. But there are ways to manually set that up. In some projects, you just have a big QA team that are actually giving you this performance statistics every week, because they just run through the game and they just dump you the information. So like, well, the game's actually 10% slower now on the CPU, but of course that's a luxury. So that's something definitely not super built in that I would like to explore, because that would be super useful to have an easy way for people to see, like, over time, our game got actually 10% more expensive in animation, 20% or twice as expensive suddenly. What happened in the last week in terms of commits? So yeah, that's kind of like where it's at right now.
All right, thank you.
All right.
I think we have one last question from the chat, actually. It says, lots of these optimizations are batch-oriented, general settings for lots of assets. Given this, how do you approach growing numbers of uniquely adjusted settings on individual assets in old scenes?
Yeah, that's a great suggestion. Well, of course, you can easily select based on class or based on object type. So you can easily like batch select those objects and then see, like, is there any object that is still using an old setting, and just override it. I guess that is one way to do it. And perhaps diving deeper into editor scripting might be a really nice way to refresh, or to even use, maybe you can create your own map check errors by overriding functions such as check for errors, I think it's called. That's existing actors, you can override those. And then maybe verify some custom information, like saying, okay, well, if it's this object, or the object is this size, maybe we never want shadows to be set. So unless we specifically have an override for that. So that might help. But I think especially just batch selecting in the editor, that's kind of like the easiest, most low-tech way to do this.